So now I'd like to talk to you about the kinds of questions we can ask for correlation and regression. Now, I could ask you to do the 6 steps to inferential statistics for both of them. And that would look something like trying to see if the slope is significantly different from 0 or if the correlation is significantly different from 0. But I feel as though you understand those inferential steps, and I'd like to move forward with asking more useful questions. Now notice that I'm combining correlation and regression together, and that's because they do move together. They should be considered together. We really shouldn't be doing a regression without correlation, and if we have a significant correlation, we should be following up with regression type questions. So that's why I've combined them. Now this question set you see in front of you is very generic, and it's the generic set of questions I would ask for any correlation regression data set. We're going to walk through them, and then you'll see we're going to go through them more specifically for our hours studied and exam score example. So the first question I would ask you is there a correlation between X and Y? That seems like a legit place to start. So I'd want to know what that correlation was, and then I'd want to know if you could interpret that number and tell me if it's significant. Then I'd ask you to calculate the coefficient of determination, and then put that number in that generic sentence. Now remember, this generic sentence is the same sentence every time, except we just replace what our Y and X variables are. So the key piece is knowing what to put in these parentheses. Those are our correlation questions, and then I could follow up with our regression questions. So the first regression question is, what is the regression equation of the line? So the answer would be y hat equals bx plus a, but you would have numbers for b and a. Then I'd ask you to interpret the slope. So the slope is that for every 1 unit increase in x, how does y change? Then I'd ask you to interpret the y-intercept. So that means when x equals 0, what will y be? Or another way of phrasing that is, how many y do you start off with if you don't have any x's? Then for question 8, let's say I give you an example and I say somebody has this particular score of x. What do you predict their y value to be? So you'd have to put that number in the formula that you already calculated. And then I would follow up with saying, now that you've given me that predicted value, how wrong are you in that prediction? And that would be the standard error of prediction. And then lastly, I'll have you do that all over again with a new prediction number so that you can see how it changes if we've given you another x value. So let's see how this looks for our specific example. So remember, we got all the results we needed from SPSS when we analyzed them earlier. Later in the video I might call it JASP because I'm splitting videos, but we did SPSS. But now I want to point out from that output the numbers that we need. If you didn't watch that video, please go back and watch that video so you know how to do that. So we'll need the correlation value, which we see is 0.707. We're also going to need the p-value, which in this case we can see is less than 0.001. So we'll need that for our report. We might need r-square, so here we see it's 0.5. Later on, we'll need this number that says standard error of the estimate. So that says 19.217. So we're going to need the standard error of the estimate for understanding how good we are at making our prediction. And then we're also going to need the equation of the line. So we're going to need the y-intercept, which we saw, these numbers are on coefficients under standardized b. So the y-intercept is the constant, which we see here is 23.074. And then we'll need the slope, which here is 2.445. So those are the things that we will need for this report coming up. So go ahead and let's go back to look at the questions. So these are all the questions we have for the example for study hours predicting your exam grade. I'm going to walk through them one by one, but now you have them all kind of in your notes if you would like to go back and review. So the first question is, what is the correlation between grade and hours studied? So we saw in our JASP output the correlation was 0.707. So that's what I'm looking for there. Now I need you to interpret that number. And really what I'm looking for here is for you to know what it means if it's a positive or negative correlation. So because this is a positive correlation, the interpretation would be more hours of study is associated with more test points. So I bolded the words more and more to remind you that when it's positive, your variables are going up together. More hours of study means more test points. Let's say it had been a negative correlation, like stress an hour study, more, that would be a negative relationship. Then that would mean more stress is associated with fewer points. So again, what I'm looking for here is that when it's a positive correlation, you see more and more. When it's a negative correlation, I would see something like more or less. Is it significant? You betcha, because when we looked at JASP, it said the p-value was less than 0.05. And here's another way we know it's significant. I shouldn't be asking you any follow-up questions if it's not significant. So it really has to be significant if I'm going to ask you any follow-up questions, because if it's not significant, I really shouldn't be asking you about the coefficient of determination or any of the other things. So the coefficient of determination you could calculate yourself. Remember, it's r squared, so that'd be 0.707 times 0.707. But fortunately, JASP did the math for us, and they told us that the coefficient of determination is 0.5. So now I want to plug that into this sentence. Remember, the key piece is remembering what to put where. We are always desiring to explain the outcome variable. That's our goal. So that's why we're going to put it first in the sentence. So our sentence is going to be 50% of the variability in test score is associated with the variability in hours studied. So it's our y variable here and our x variable at the end. Most common mistake I see in exams is switching these two. So remember, we're trying to explain outcome variables. So that's why we're saying the 50% of the variability in our outcome variable. So those are our correlation questions. Let's move on to our regression questions. So the first question is, for regression, what is the equation line predicting y from x? In other words, predicting exam score from hours studied. So here's how I put it together. Rather than using the actual hat over the y, I just wrote it out like this because it's easy to write out with typing, and I want to show you on a test how you might be able to write it out. But if you wanted to draw a hat over the y, that would also work. I wouldn't accept that y equals anything. It has to be the hat. But remember, we pulled these numbers out from JASP. So we found our slope to be 2.445, and we found our y-intercept to be 23.074. So this is how it would look. Now I want you to interpret the slope. This means for each additional hour studied, how does your grade change? Well, it's going to go up 2.445%. Do you see how that's helpful? Let's say this information was real and you're trying to decide whether it's worth studying an extra hour or whether you should just stop here. Well, if you knew that if you studied an extra hour, it would bump your score up 2.445 percentage points, then maybe you would want to study that extra hour. Now we're going to interpret the y-intercept. So what grade can we expect if someone didn't study at all? In other words, we're going to be setting x to 0. That's the definition of our y-intercept. So we're basically saying you would get roughly about 23.074% on the test. Do you see how we are interpreting these numbers one by one? Now let's do the fun stuff. Let's say Bob comes up and tells you, well, I studied 15 hours for this test. Let's predict what Bob would get for his grade. So we would plug his 15 into the equation we have up here. So for x, we're going to put in his 15. So we have 2.445 times his 15 hours plus the base of 23.074. So when we do that math, we get 59.75%. So we predict that Bob will get about 59.75% on the test. But Bob might ask, well, how wrong do you tend to be in your predictions? And so remember, we were able to get that information from the root mean squared error in JASP, and that was, they're out of order, plus or minus 19.22%. So Bob, I predict you're going to get 59.75% on the test, but I tend to be wrong about 19.2%. So then Bob might take that and try to use that information to decide what his test score is going to be. Now let's say that Sue, this is missing the 30, I apologize. Let's say Sue studies 30 hours. What is her predicted grade? So we're just going to do the same thing we did with Bob, but with Sue. So we plug 30 into the equation just like we did Bob's 15. And then we would calculate her score, if we do that math, to be 96.42%. But we tend to be wrong about 19.22%. So give or take 19.22. Now, sometimes students get worried because they think, this is over 100%. And we recognize that. This is statistics. We're okay with that. We're just trying to say that on average, we are wrong about 19.22%. One of the reasons why I ask 8, 9, and 10 is because I want you to prove to me you understand that Bob has the same error rate as Sue, and that is the indication for homoscedasticity. So if we had different error rates for Sue and for Bob, then we would be violating homoscedasticity and we shouldn't be using the least squares regression model. So what we have seen with these 10 questions is all the kinds of things I might be able to ask you with correlation regression after you've analyzed your data. Now let's go have some more fun with some other examples.